Okay, so in this video, let's discuss some additional ways that we can create matrices using binding functions. So we're going to talk about the cbind and the rbind function, which are ways that we can build a matrix from vectors that we've created. So let's consider the following first code cell here, which is first going to create two vectors. I'll call vec1 and vec2. So vec1 is the integers from 1 to 4. So here we just have a one-dimensional object, 1, 2, 3, 4. Vector 2, this is going to be a vector of the integers 5, 6, 7, and 8. So I've got these two vectors. And from these two vectors, I can create a matrix using the cbind function, which is going to bind these two vectors together as two different columns. So if I run this code cell over here, oh, excuse me, I need to first run that one. So this has defined these vectors, vec1 and vec2. And then I can run this code cell, cbind vec1 comma vec2. And this joins these two vectors together as the columns of a matrix. So vec1, that becomes the first column. Vec2, that becomes the second column. So this is a 4 by 2 matrix. We have 4 rows, 2 columns arranged in this way. And you can see now in this print, when I displayed this on screen, it is actually using vec1 and vec2 as a label, as a name for each of the columns. So it almost looks a little bit like a data frame because these columns are now given names by the vectors. If I did a print command on this, we can see if the output would look any different. And when I do the print command, it looks a little different because this includes like the index for the rows over here. But now this is saying if I want to index column 1, I can do it using the name vec1. And column 2, that is now named vec2. But these are just matrices, and in this case, it's a 4 by 2 matrix. Another way that I can bind these two vectors together would be using the rbind function, which is the row binding function, which is going to take these two vectors, and the first row would be vector 1, the second row is going to be vector 2, and over here, I'm just going to pipe that output into the print command. So I'll get output that looks similar to the output that we had above. And so now when I do an rbind function, our matrices have the same values, but the way they've been ordered in the matrix through the rows and the columns are different. And this gives me a matrix that has totally different size. This matrix only has 2 rows and it has 4 columns. When we created it with the cbind function, we had 4 rows and 2 columns. rbind means row 1 is vec1, row 2 is vec2. So I've got 2 rows and now 4 columns. So these are just additional ways that you can create matrices, and we'll see why these binding functions are going to be useful in the context, say, of doing some linear regression shortly in this video. The next thing I want to talk about while I've got you here is to talk about the size of a matrix. So we, again, give the size of a matrix by indicating how many rows and how many columns are in the matrix. First giving the number of rows, then giving the number of columns. In R, there is a function called dim, which is going to give me both the row and column dimensions of matrix A. So matrix A, just so that you're aware, is we initially stored earlier as this matrix over here, a 5 by 2 matrix. So if I will run this, let's just make sure I've got the right matrix A. So what we've got stored as matrix A is this 5 by 2 matrix. So if I say dim A, it should tell me that it has 5 rows and 2 columns. The notation, at least it displays differently when you're working in Colab. as it would if you were working in RStudio. But when you're displaying this output in Colab, it uses a dot to separate the two values. So just keep that in mind. This is not 5 times 2, but this is like 5 comma 2. So it's really saying the first number 5 is the number of rows, the second number 2 is the number of columns. If I try to run this dimension function, this dim function using a vector, so vec1, that was just this vector of integers 1, 2, 3, and 4. And if I say, hey, what is the dimensions of vector 1? It gives me a null output here because the dimension function is looking for an input which is a matrix. Vec1 is not a matrix, so it's telling me this is null because it doesn't have any columns. It only has one dimension to give. So if I want to calculate how many things are in a vector, then we can use the length function, and that tells me that vector 1 has 4 things in it. So it's a different function. If I want to determine how many elements are in a vector, I can use length. If I want to determine both the number of rows and columns of a matrix, then I can use the dim function. And sometimes it's useful to extract just the row, just the number of rows or the number of columns. So just keep in mind that when I run the output, when I run dim A, it creates a vector. So this is a vector that has 2 entries. The first entry is 5, the number of rows. The second entry is 2, the number of columns. So if I want to extract, just tell me how many rows does matrix A have, I can run the dim A function and then in square brackets indicate afterwards, just tell me the first element of this vector. This vector dim A has 2 values, 5 and 2. So this is say, give me the first value, which is 5. That's the number of rows. This is telling me, give me the second entry in this vector of output. The second entry is the 2, and that's telling me how many columns A has. If I just want to get a single number for the number of rows or the number of columns that a matrix has, there are also functions nrow and ncol that will give me just that one value. So if I say nrow A, it's going to give me 5. That's how many rows matrix A has. And ncol A is giving me an output of 2 because matrix A has 2 columns. So whether I do this, whether I get the number of rows using the dimension, the dim function, and then extracting just the first value of that I get from the dim vector, or whether I use nrow, I get the same output of 5. And whether I want to use the dimension function dim A and tell me the second value of that, or whether I just want to say, tell me the number of columns in A, they'll both give me the same output. So when you're writing code and setting up maybe loops and other things, sometimes it's really helpful to be able to store the number of rows of the matrix someplace, store the number of columns of that matrix someplace, and then maybe use those values as like indices in a for loop or something like that. But we'll tie this into loops and other things later on. For now, right now, we're just talking about what is a matrix and how can we work with them in R.